Welcome to the software journey with GKey. Data warehousing concepts with real-time interview questions and answers. Lesson number 17. Explain OLAP technologies like MOLAP, ROLAP, HOLAP, cubes and aggregations in data warehousing.
In this part of training, we are going to discuss about what are different OLAP technologies. That too, MOLAP, ROLAP and HOLAP. OLAP is online analytical processing. It is used for multi-dimensional analysis, reporting and dashboarding and cube-based analytics. There are three OLAP systems or types available. First one is MOLAP, that is multi-dimensional OLAP. Second one is ROLAP, that is relational OLAP. And third one is HOLAP, that is hybrid OLAP. Plus cubes and aggregations and pre-aggregations. This means these modes like OLAP modes are available in cubes concept, that too in SSAS, that is SQL Server Analysis Services in MSPS stack. Let us discuss first the MOLAP, that is multi-dimensional OLAP. Coming to the definition, data stored in multi-dimensional cube format, not in SQL tables. See, in like MSBA stack, we have a tool called SSAS, which is SQL Server Analysis Service. By using that tool, we can prepare cubes. Instead of tables, cubes are going to store their data in multi-dimensional format. These are uses highly compressed cube files. This is a fast query performance. That means for faster query performance, what we are going to do is we are going to create a cube. The aggregations are pre-compiled and stored in that cubes, and when you run any report on top of that cube, you can get the faster performance. That is like here multi-dimensional OLAP. Data is stored in multi-dimensional cube format. When it is used, when data volumes are moderate, when fast performance is required, when pre-aggregation reduces query time significantly, in these situations we are going to use this MOLAP, like multi-dimensional OLAP thing. Coming to the examples, Microsoft SAS multi-dimensional, Cognos PowerPlay and Oracle SBase and MSBI SSAS. These are the different things that we can use. That is Microsoft SSAS is the main tool that I have used in my real-time systems. Coming to the MOLAP architecture diagram, this is the data warehouse tables and this is the cube processing. Based on the tables, we are going to prepare a cube. These cubes are pre-aggregated data, and then the data is stored in MOLAP cube storage, that is multi-dimensional, and on top of this we are going to prepare BI, business intelligence or reports for faster performance. Coming to the next slide, key characteristics of MOLAP are they are stores data in cube format, dense and sparse, fastest OLAP storage, and it requires processing to refresh data. It is highly compression. High compression is available in MOLAP. And the next OLAP model is ROLAP, that is relational OLAP. Definition for this, data is stored in relational tables, that is dimensional modeling, dimension tables and fact tables. The data is going to be stored in dimensions and fact tables. No special cube storage. Cube is like visual here in this scenario. When this ROLAP is used, when data size is very large, when real-time analytics is needed, when users query directly from the warehouse. These are the situations we go for ROLAP technologies. And coming to the examples, SSAS tabular, that is direct query mode, MicroStrategy, business objects. These are the different tools that are available for this kind of ROLAP technologies. ROLAP architecture is here fact table, dimension table, kind of fact and dimension table things are there. On top of that, OLAP engine, that is ROLAP, is to happen, and then reporting is to happen. Coming to the key characteristics, No cube storage here, uses SQL only. It is slower than MOLAP but supports huge datasets, real-time available, easy to scale. These are the different characteristics of ROLAP. Coming to the third type, that is HOLAP, which is hybrid OLAP. Definition is it is a combination of MOLAP and ROLAP. Detailed data kept in relational tables, that is fact and dimension tables, and aggregate data is stored in multi-dimensional cubes. When it is used, when data volume is huge but performance is needed, when both detailed and summarized data are required. Coming to the HOLAP architecture diagram, this is MOLAP cube with aggregations and pre-aggregations, and this is fact and dimension tables with detailed data. On combination of this, HOLAP engine works, and finally we are going to prepare the reports for users and business. And coming to the key characteristics, it is best mix of speed, that is MOLAP, and scale, that is ROLAP. Summary queries are fast. Detailed drill downs hit relational tables. And final concept is cubes, that is OLAP cubes. Coming to the OLAP, an OLAP cube is multi-dimensional data structure used for analytical queries. Dimensions in cube are like time, product, customer, geography, scenario. These are like actual budget and forecast scenarios that we will be having in dimensions in cube. That means these are the different dimension tables which are available in the cube. Measures inside cube are like sales amount, quantity, profit, and margin. Once we create any cube, these are the dimensions available, and we can make some of the measures out of the values available in the dimension tables and fact tables. Coming to the cube diagram, here timetable, that is date table, which is having years, months, and days of data. Cube space, and here it is a product and a customer. These are different dimension tables, and these are different measures which are available over there. Characteristics are like in cube we can drill down, roll up, and we can slice, dice, and pivot the data in the cube, and we can use them for the reporting. And final point in OLAP technologies is aggregations and pre-aggregations. These are the concepts which are in OLAP cube. The definition of aggregations and pre-aggregations are: these are pre-computed summary tables are cube partitions that store aggregated values. That means from relational database we can connect and create a cube. On top of that we can create some aggregations. We can schedule these cubes at particular time. They will pre-aggregate the values and stores into the cubes. Purpose of this aggregations and pre-aggregations are like dramatically reduce query response time. That why? Because these are pre-aggregated. Reduce runtime calculation needs. Speeds up dashboards. That means finally for the performance of the dashboards we are going to use as aggregations and pre-aggregations. For example, fact sales contains 100 million rows. If you have a query like this, select product year sum of sales from fact sales group by product and year. Instead of scanning 100 million rows each time, a pre-aggregated table is built. On top of the table, the data is going to be displayed without wasting time. I think you got some idea of OLAP technologies which are available in data warehousing. Thank you.
Follow us on YouTube, LinkedIn, Instagram, and Facebook. Don't forget to like, share, subscribe, and press the bell icon to stay updated with our latest content. Join the GKey community and grow your IT profession with us.